I'm Anil Kumar. Welcome to my series on complex numbers. We'll discuss product and reciprocal of complex numbers in this particular video. I have a few examples which will help you to answer any question on complex numbers as far as the operations on complex numbers is concerned. Question number 1 here is find the value of I to the power of 99. Question number 2 is show that 1 over a plus bi is equal to a minus bi over a square plus b square. Now this is a very important relation. We are saying 1 over the complex number z is basically equals to its conjugate, right? You may write like this, over the square of the magnitude of the complex number, right? So you could interpret this as reciprocal of the complex number is conjugate of the complex number divided by its magnitude square, okay? Third question here is express 2 minus 3i over 3 plus 2i in a plus bi form. So here we'll learn the process of rationalization, right? So in fact, in both of them, we'll actually do rationalization. That is to use conjugate, right? So we'll use conjugate to help get this solution. Find square root of 8 plus 6i is also a very interesting question. So in this particular case, we'll actually assume this to be equal to a plus bi, and since we want to find square root of this, we'll actually square this and then figure out the correspondence, right? So square root of this really means that we'll find this square, right? So if I find this square, then a plus bi, in that case, a plus bi will be equal to square root of 8 plus 6i. You get the concept. So that is how we are going to solve this particular question. Now the next question here is find quadratic equation with given roots, and these are complex roots. So how do we find quadratic equation here? Well, we will use the concept that these are the two roots. So the quadratic equation will be x squared minus sum of roots times x. Let me write z because we are working with complex numbers. Let me write z, no problems, right? Sum of roots plus product of roots. Equals to 0, right? Because those roots will give 0 for it. Perfect. So that is how we could actually get the quadratic equation. You may write z or x, whatever, any parameter you like. Important thing here is to remember that the coefficient of z will be sum of roots and the constant term is going to be the product of roots. Now z is better since we know we are working with complex numbers. We'll get I in between, right? Solve the equation a plus bi whole square equals to, there is a misprint here. I wanted to write I, it has become capital I. So a plus bi whole square is equal to I, where a is greater than 0. So very interesting question. Now let us see how to answer these questions one by one. So these are actually the questions which you should know while working with complex numbers in case you want to solve all the questions related with operation of complex number. Perfect? Okay. So let's begin with I to the power of 99. Now it is a very popular question to find the values of I to the power of something, right? It could be 99 or any number. So here I'll also discuss with you a simple concept which can help you understand what this means. So we have a real and the imaginary number x's, right? So when I say we are working with I, then this is I. Is it okay? So I is here. So as soon as I multiply with I, then I get I square. I square is nothing but minus 1, correct? And then once again I multiply by I get I cube, and I cube is minus I, correct? And next time when I multiply by I get I to the power of 4, which is 1. So every multiplication by I results into rotation by 90 degrees, right? So that is what is very important to understand. And if I do I to the power of 5, the process repeats, right? So I to the power of 5 and so on. So what you understand is that all the multiples of 4 will be 1. All the multiples of 2, I should say, yes, that is okay. And these two squares will be minus 1, correct? Now, I have I to the power of 99. So I could write I to the power of 99 as what? Well, I could write this as equal to a multiple of 4 will give me 1, right? So the closest multiple of 4 is 96, right? 96 is a multiple of 4, and then I could say I cube, right? So we know I to the power of 96 is 1, right? Since it is a multiple of 4. And then we are left with I cube as our answer. So our answer is equal to I cube. Is that clear to you? Perfect. So that is how you could actually answer this question. Now some of you could also use the mod operator, right? Mod 4 to answer this question, right? So that is also very interesting and easy to figure out, but really basically means that you have to write this number as a multiple of 4, which helps. So for you, you can do now the question of I to the power of 1007. It is easy, right? 1007. So figure out what is this answer, right? Let this be a question for you. Next question here is, show that the reciprocal of any complex number is equal to its conjugate divided by its magnitude, right? That is a very important property, right? So let's try to prove it. So we are given 1 over a plus bi. Now we will rationalize this. That is to say, we'll multiply by a minus bi and also divide by a minus bi. So this process you have learned is similar to rationalization, right? So we are using the conjugate, right? So we are using the conjugate to rationalize. So I'm just trying to go from the left side, and so now what do you get? So in the numerator we get a minus bi, which looks familiar, the right side, perfect. And here we'll just multiply them, right? So when you multiply them, what do you get? You get a times a as a square. And a times minus bi, you get abi, and then with b, you get plus abi, and then that square with negative b square, I square. You know, I square is equal to minus 1. So, in this we see these two terms cancel, and what am I left with? A minus bi over a square minus b square times minus 1, right? So I square is minus 1, and that gives us what we need, which is a minus bi over a square plus b square. Perfect. So this is a very, very important relation where we can say reciprocal of a complex number is equal to ratio of its conjugate and magnitude square. Does it make sense, right? So this is the magnitude square, right? So I could write this as, let me use like this, 1 over z, this complex number, could be written as the conjugate over the magnitude square of the complex number. Clear? The next question here is, we need to write it in the form of a plus bi. So basically, we again have to do rationalization. So you can actually pause at this stage and answer the question. So we have 2 minus 3i over 3 plus 2i. We'll just multiply by 3 minus 2i and divide by the same thing. So what do you get? So in the numerator, we get 3 times 2, 6. Then 2 times this gives you minus 4i. Right? And here we get minus 9i. This becomes plus, and 3 times 2 is 6, and we have I squared. We'll make it negative in the next term. And here we learned just now that it should be 3 square plus 2 square, right? Can I write like this? We just did it. So I'm not expanding it the way we did the numerator. You could do it, okay? Now, combine, rather, first we'll write this as minus, and then we'll combine, okay? So 6, we can combine these two, which is minus 13i, and here we get minus 6, right, over 3 square is 9 plus 4, correct? So that gives you 6 minus 6 is 0, so we get minus 13i over 9 plus 4 is 13, and that gives you minus I. So in this particular case, since we get minus I, so A is equal to 0 for us, and B is equal to minus 1. Is that clear to you? Right. So this is very important question. We get A as equal to 0 and B as equal to minus 1. Correct? So let's check our calculations. 2 times 3 is 6. 2 times minus 2 is minus 4i. With negative 3 you get minus 3 9i, and that becomes plus minus minus 3 times 2 6 I squared, which makes it negative, and therefore 6 and minus 6 cancel, right? So we could always write this as 2 minus 3i over 3 plus 2i equals to 0 minus I. So that means A is 0 and B is minus 1. Clear? Now here is another question which is extremely important. I would like you to pause the video, try to do it on your own, and then look into my suggestions. We need to find the square root of 8 plus 6i, right? So let us assume that x plus yi is equal to square root of 8 plus 6i, correct? So that really means that x plus yi whole square should be equal to 8 plus 6i. Now, let us expand this and try to relate the real and the imaginary part. So when I expand this, I get x squared plus 2ab, which is 2 times x times y times I, plus y square, which is y square I square, and that should be equal to 8 plus 6i. Now I square is minus 1, so we get x square plus 2xyi minus y square equals to 8 plus 6i, correct? Now we can equate the real and the imaginary part. So this is the imaginary part which we'll take, and the real part is x square minus y square, which will be 8. So we get here two equations. The first one, let's write the imaginary parts, which is 2xy should be equal to 6. Now from this part, we can actually write one variable in terms of the other. So we can say that means that y is equal to 6 divided by 2x, right? So which is as good as 3 over x. So that is the value of y, correct? Now we are going to substitute this value of y in the second equation. So let me write this as equation number 1. Now, the second part of this is that we have x squared minus y squared is equal to 8. Now in this, we'll substitute y equals to 3 over x, correct? So we'll have it here as x squared minus 3 over x whole square equals to 8, and that gives you x squared minus 9 over x squared equals to 8, right? So we have a quadratic equation in a way because there is x squared in the denominator. So let's now solve this particular equation. So let me rewrite here by cross multiplication. So I get Okay, let's rewrite the whole equation. We get x square minus 9 over x square equals to 8. So multiplying by x square, we get x to the power of 4 minus 9 equals to 8x square, correct? Bringing all the terms together, we get x to the power of 4 minus 8x square minus 9 equals to 0. Now that is a quadratic equation. We can do sum and product, right? So we could do minus 9 times 1. That will give us minus 8. So I could write this as x square minus 9 times x square plus 1. Correct? Equals to 0. Now, see, x and y are real numbers. So when you write this equation here, remember, x and y belongs to real numbers, right? They are not imaginary. So here, what do we get? This equation gives us two solutions. X is equal to plus minus 3. That is not a solution since x is a complex number here, right? So we'll work with two solutions of x which are plus and minus 3. Now, we know that the x value could be either plus 3 or minus 3. So we'll take x equals to plus 3 and x equals to minus 3, and we know what y is, right? So we know y is equal to 3 over x. So if I take x as plus 3, so I could write this as 3 over 3, so we get y equals to 1. And here, if I write y equals to 3 over x, and if x is minus 3, it is 3 over minus 3, so y equals to minus 1. You get the idea, right? So we are getting two answers. So the first answer here is for x equals to 3 and y equals to 1. And here for minus 3, we get y equals to minus 1. And therefore, looking into that particular equation, what are our solutions? It is x plus yi, right? And therefore, the square roots of this are 3 plus 1 times I is I, and 3, this is minus 3, minus I. Does it make sense to you? So those are the two square roots of your complex number, right? So these are our solutions. Is that clear? So that is how we get our solution. We have two answers here. One is 3 plus I, and the other one is negative of this, right? So basically, you could also write this as it is plus minus 3 plus I. So that becomes the solution for the given question. I'd like you to go through these steps once again and see how such equations can be solved. It is a very important question from test point of view. Find the quadratic equation with roots 1 plus 2 square root 3i and 1 minus 2 square root 3i. So we could write, let the quadratic equation be what? Let the quadratic equation be z square. So now, when you're talking about roots, right? Let's say the roots are alpha and beta, right? Let's say this is alpha, this is beta. So these are the two roots. Then the quadratic equation should be negative of alpha plus beta, the sum of roots, plus, times z, plus the product of the two roots, alpha times beta. Is that clear to you, right? So that is how we are going to get the quadratic equation equal to 0. Perfect. Now we know these roots. So let's find their sum and product, right? So let's work it out. So we have alpha equals to 1 plus 2 square root 3i. Beta equals to 1 minus 2 square root 3i. So they are normally conjugates. So that is how we get them. Now alpha plus beta is what? So when you add them up, we get the number 2, right? They cancel. Perfect. Now let us do their product. What is alpha times beta equals to? That is to say 1 plus 2 square root 3i times 1 minus 2 square root 3i. Correct? So when you multiply, you get a square minus b square. You get 1 minus. So 2 square root 3i whole square. Correct? So sum and product formula, right? So 1 minus. The square of this will be what? Square of 2 is 4. Square of square root 3 is 3, right? And then we get I square. Now clearly, I square is negative 1. That will make this positive. So we get 1 plus. And 3 times 4 is 12. right? So where we get this as 13 as 1 plus 12. Now we know sum and product, and therefore we can write down the equation, which will be z square minus the sum, which is 2z, plus the product, which is 13, equals to 0. Do you see that? So that is how we get the solution of this particular equation. So I hope that helps, correct? So I like you to check the solution, right? So as a part, what you should say is, question for you is to check if it is true, okay? Find the roots. Okay, now I think we are almost at the end. The last question for us is to solve the equation a plus bi whole square equals to I, okay? We are also given that a should be greater than 0. So we need to solve for a plus bi whole square equals to I. So let's just expand this. We get a square plus 2ab I plus bi whole square equals to I. That gives us a square plus 2ab with I, and that is plus, let me write bi square equals to I. So let's continue. We get a square plus 2abi minus b square equals to I. Minus because I square is negative, right? So we have real part, which is a square minus b square, and we have a complex part, which is imaginary part, which is 2abi equals to I. So that gives you two conditions, right? So always when you solve, you get these types of conditions. So we say, well, a square minus b square should be equal to 0, and 2ab should be or equal to 1, correct? These two terms are equal. The imaginary part should be equal, right? And the complex part, think like this. This is like kind of plus 0, right? So the complex part is 1, but the real part is 0. So that gives you the first equation, and the other one is for comparing the imaginary parts. So these are your real parts and this is your imaginary part. So that will help us to provide the solution. We have to work with a greater than 0, right? So from here we know a square equals to b square, correct? So their values are same, and here we know that we could write a as equals to 1 over 2b, right? 1 over 2b. Now, so if I replace one of them, right, for example, then I can actually get the solution. So if I write, instead of a square, I write 1 over, either one I could do. So here let me write 1 over 2b. So 1 over 2b whole square will be equal to b square, correct? So that is how we get. So we could actually get rid of square root and we get 1 over 2b equals to b. Now cross multiply, so half is equal to b square, and so we get the value of b as 1 over square root 2. So we get 1 over square root 2 as equal to b, correct? Now since they are squares, they actually will land up with positive values, perfect? And since this is 1 over square root 2, I can say a square, they both are same, right? A square equals to b square means a equals to b. I should write like this actually, a equals to b, right? That was simpler. So I could have written a plus a equals to b, and since b is equals to 1 over square root 2, that is the same value for a also, right? So solve this equation for I. So the solution is that a and b both are equal to 1 over square root 2. Is that okay? So that is our answer. So the answer here is that a equals to b equals to 1 over square root 2. Okay, so since we are saying that a is always greater than 0, at this stage itself I could have written a equals to b and then solved, right? So if I substitute here a or b, we could have done and got the answer. Anyway, so I hope you understand and appreciate how we could solve problems related to complex numbers. So we have actually in this particular exercise done all kinds of operations which you will be expected to do for complex numbers, right? So that actually completes the chapter as far as the arithmetic of complex numbers is concerned, right? So we found the powers of I, we found the conjugate, we found how to multiply them, right? And express them a plus b5. We also found a method of getting the square root, which is quite complicated. And then we solved, or we got the quadratic equation from the given roots. Perfect. And we solved an equation involving complex numbers. I hope that makes sense. Feel free to share my videos, and if you have any doubts, you can always send me an email on the address given here. Thank you, and all the best.